In some cases, you want to cancel a long-running operation. This could be an API call, the process of loading a large file from disk, or really anything that you wrap in a task. In our application, for example, maybe we start the process of searching for a stock, but we immediately see that we've entered the incorrect company, and therefore we'd like to correct this by allowing the user to cancel the search and correct the mistake. Because I know this goes ahead and loads a large file, and that could be a pretty expensive operation if the file is really big. It's rather unnecessary to force the user to wait for that operation to complete. In an ideal scenario, if we cancel the operation, the data that it has already loaded should definitely be displayed in the UI. To allow a task to be canceled, there are a few things that needs to be done. First, we need to introduce a member inside our class of type cancellation token source. This is what we are going to use to indicate that we want to cancel an operation. This class exposes methods for signaling for cancellation. It even provides functionality to indicate that you want to cancel after a certain amount of time. We'll introduce this cancellation token source as a member in our class. We don't want this limited by the scope of the click event handler. The cancellation token source is coupled with something called a cancellation token. The cancellation token is what is passed into an asynchronous operation. This token can be used to indicate to a task that it's canceled, but it can also be used within an asynchronous operation to check if a cancellation has been requested. In our case, we are going to use the same button for searching, as well as allowing the user to cancel the search. I reckon this is a pretty common pattern. If there's already an instance created for the cancellation token source, that means we've already started a search and the button has been clicked before. If that's the case, we know that something's currently performing a search. We'll then signal that we want to cancel all the operations that use the cancellation token produced by this cancellation token source. Then we'll also set the cancellation token source to null. We'll reset the search button's text and return from the method. Because obviously, we wouldn't want to continue running the code beneath to start a new search. That would kind of defeat the purpose of canceling it. This code takes care of the case of when the search button is clicked for a second time. If it's the first time we hit search, after a previous search has completed, we'd like to run the code below that handles loading and displaying the stocks. Before initializing the search, we need to make sure that we have an instance of a cancellation token source. We'll also set the search button text to cancel. This will make the UI a little bit more intuitive. If there's no cancellation and the asynchronous operation completed successfully, we'd like to set the text on the search button back to the original text, as well as setting the cancellation token source to null. If you don't, you'll get some really interesting bugs. I do urge you to play around with that yourself. This method is getting rather big. Let's just refactor a few parts of the method to a new one. I extracted the code that loads the file from disk and maps that to a stock price to a different method. This method now needs to be capable of canceling that operation. Let's add a parameter to the method which will allow consumers of this method to pass a cancellation token. As mentioned earlier, the cancellation token is what is used to keep track of a cancellation. You might have already spotted this. Task.run provides an overload that allows you to pass a cancellation token. Let's use the cancellation token that we've passed into the method. In search-click, where we call this method, we also need to make sure that we pass the cancellation token. The first time the click event handler is called, it will create the new cancellation token source with a brand new cancellation token. The second time it's triggered, there will already be a cancellation token. It will then signal to the previously created cancellation token source that it needs to cancel. What do you expect this to do? Let's run the application and see how it behaves. Search for a stock and then quickly hit cancel. Why didn't this cancel the search? The cancellation token passed to task.run does not automatically terminate the operation. In fact, it's only relevant when starting the operation. If the cancellation was requested before task.run executes, it would know that the cancellation had been requested, and therefore it wouldn't run the asynchronous operation. Then, how do you properly cancel the operation? The problem is, how would your code know where and when to cancel, and really what to do when you've requested a cancellation? It won't just magically be canceled because you've passed a cancellation token and signaled for a cancellation. You need to handle the cancellation as well. Given that we've already refactored the code for loading each line from disk asynchronously, this gives us the opportunity to just return the amount of lines that we've already loaded when there's a cancellation. This means it's handled gracefully. In the iteration where we load each line asynchronously, we can check if a cancellation has been requested. If a cancellation has been requested, we want to do something about that. Using the cancellation token variable inside the anonymous method means that we capture this variable and it's available throughout the asynchronous operation. The cancellation token provides a property to check if a cancellation has been requested through the cancellation token source. We could also call the method throw_if_cancellation_requested, which would throw an exception if it's been requested to be cancelled. Calling this would throw an operation cancelled exception. Doing so will mean that the exception is captured in the task, it's set to a faulted state, and you can then properly handle that inside your continuation. To handle our scenario better, we're going to check if the cancellation is requested. If that happens, we'll just return the amount of lines that have been processed so far. When we return that from the task, its continuation will execute, as long as we haven't specified a task continuation option to say otherwise. You can pass the cancellation token to the continue with method as well. The same principle apply here. It won't magically be cancelled when the cancellation is requested. You could introduce a continuation that only runs when a task is cancelled. A word of advice: it won't run a continuation with the task continuation options set to only on ran to completion if the task is marked as cancelled. Run the application and let's search for a stock. We requested a cancellation. It cancelled the operation of loading more lines, then continued to process the lines, then populates the data grid with the stocks that it had time to load. You could now experiment with introducing the cancellation for the continuations as well. If you need to specify both the task continuation options as well as the cancellation token, you also have to set another parameter. This parameter is specifying the task scheduler. To keep it simple, you can use taskscheduler.current, and this will use the task scheduler that is associated with the current context. Finally, there's one more thing I want to add. I want to add a note in the application whenever a cancellation has been requested. Although, I don't want to associate that functionality with our task and simply append a continuation. I'd rather use an alternative approach. I'd like to request the cancellation token to let us know when there's a cancellation. The cancellation token allows you to register a delegate that will be called when the cancellation token is cancelled. This will execute on our context, so we can invoke the UI from this anonymous method. In this action, let's just update the UI to say that a cancellation was requested. As you now search for something in the application and immediately request a cancellation, we can see that this worked. It now added a note to tell us that there was a cancellation. This shows how easy it is for us to introduce a cancellation by using the cancellation token source together with a cancellation token. This provides functionality to request a cancellation. We also got an understanding of the fact that we need to handle the cancellations gracefully and that it won't just automatically terminate an operation. I'd like to give a word of advice on how you chain your continuations. Have a look at this example. Each continuation we see here is registered with the task at the top. If the cancellation token is set to cancelled, the task passed into the continuation will notify you that it's been marked as cancelled, which makes a lot of sense. If we change this code and chain the continuations together, meaning that we'd add the continuations to the task that is returned from continue with, we'd get a little bit of a different result. This is because only the first continuation has a reference to the original task. The subsequent continuations reference the task of the previous continuation, and that have not been marked as cancelled. This is something that could potentially introduce bugs, so keep this in mind.